Okay, so 10.4 deals with multiplying, really adding, subtracting, and multiplying radicals. So we should have seen adding and subtracting already on the previous video, so now we're multiplying. So when we multiply radicals, we're going to apply the same rules that we did when we had just basic expressions. So what I mean by that is 3 times x plus 2. So when we distribute, we would just distribute. So 3 times the x and then 3 times the 2. So what we're doing now is we're just really doing the same process. So the 3 is multiplying to the invisible coefficient 1, just like it multiplied to the invisible coefficient 1 on the regular x. So it would be 3 square root x plus 6. Okay, so let's look at square root of 3 minus square root of 10 squared. So we have a binomial raised to the second power. Well, we're supposed to already understand what that means. So let's look at an example over here. So x plus 3 squared means x plus 3 times x plus 3. And then what will we do? Well, we would FOIL it or distribute it out. So x squared plus 3x and distribute by 3, right? So x squared plus 6x plus 9. So that's how we would simplify that. So in this particular problem, we would write it twice, which I cannot fit it right there. Hold on. So square root of 3 minus square root of 10 times square root of 3 minus square root of 10. So what do we want to do here? Well, we want to FOIL or distribute. So square root of 3 times the square root of 3. So here's where we should have a special rule that comes into play. So there is a rule that tells us that the square root, any square root of a times the same square root of a would just give you a. So that's just a special rule to know. So when you know that special rule, you can use that in a problem like this. So square root of 3 times the square root of 3, you could just know automatically that it's a 3. But I'm going to go through the whole process with you. So square root of 9 minus square root of 3 times square root of 10. So whatever is under the square root multiplies to each other. So 3 times 10. So square root of 30. And then inside, square root of 10 times square root of 3, square root of 30, square root of 10 times square root of 10 minus square root of 100. So we're writing it, and now we're going to simplify. So simplify would be square root of 9 is a 3. Negative square root of 30. So can we break down the square root of 30? So let's check. 30 has 3 times 10, 2 times 5. So there's no pairs inside of a 30. So the square root of 30 doesn't simplify, but I can combine like terms here. So negative 1 minus 1 is a negative 2 square root of 30 minus square root of 100 is a 10. So like terms would be 3 minus 10, so negative 7 minus 2 square root of 30. And that's it, okay? So if you know your shortcut from when we multiplied originally, square root of 3 times square root of 3 would have just been 3 minus square root of 30 minus square root of 30 minus 10. So then we would have just had 3 minus 10, which is negative 7, and then minus the 2 square root of 30. So you can actually just multiply it and then simplify, or if you understand your rule, you can just apply your rule when you're multiplying radicals. Okay? All right, let's look at this one. Square root of 6 times square root of 6 plus y square root of 30. So again, this is just a distribute. So we're distributing here. So square root of 6 times square root of 6. Again, you can do square root of 36. For this one, I'm going to just write 6 plus y times the square root of 6. Y square root of 30 times square root of 6. So 6 times 30 is 180. So we have 6 plus y square root of 180. So we're going to break down 180. So when we break down 180, I get a pair of 3s, and I get a pair of 2s with a 5 left over. So 6 plus. What happens? Well, the 3 comes out, the 2 comes out, the 5 stays inside. So 6 plus 6y square root of 5. Final answer. And that's it. So we've distributed and we multiplied. All right, let's look at this one. Cube root of a plus 2 times cube root of a plus 2. So again, we're distributing. So cube root of a. So cube root of a times cube root of a is cube root of a squared. So we keep the radical and we just multiply the contents that's inside the radical. So a times a plus 2 cube root of a. Then we're distributing inside. So plus 2 cube root a plus 4. So we see if we can simplify. Cube root of a squared cannot break down. So I do have like terms, right? Like terms means everything behind the coefficient matches. So I get cube root of a squared plus 4 cube root of a plus 4. There are no like terms present. That problem would be complete. Make sure when you put in your answer that you remember it's a cube root, not a square root. That's important. Little things matter. Okay? And that's multiplying radicals.